So in this video, we're going to be learning about some of the newest features in Python 3.6. So the first nice addition to Python 3.6 is the way you can format numbers. So if I wanted to print out a number with a lot of zeros, I could type it in and I could hit enter and it would print the number. But when you get lots of zeros in a number, it can become very hard to read. So Python 3.6 adds the ability to add underscores in between your digits, and Python will ignore those underscores and print the actual number. So if I run that now, you can see it prints the same number. You can also put the underscores anywhere in the number, so I could say 1_0_0 and it would print 100. But one of the best new features in Python 3.6 is called type hints or type annotations. So Python is a dynamically typed language, so when we create a function like this, we create a function with a and b and we can add a and b together. But a and b can be any data type that we want. A and b doesn't have to be two numbers, it could be two integers, two floats, two strings, and the Python runtime will be able to work it out. But this can make things unreadable for programmers, because if you're working on a function and then somebody else comes to look at your function, they're not always going to be able to tell what kind of data the function should take. It's also handy for IDEs, because at the moment IDEs can look at this function and there's very little they can do to figure out what the type should be. So they can't give you as good error messages. So with type annotations, what we can do is we can put a colon and then a type, so in this case int, and then another colon and then a type to specify that these two arguments are going to be integers. And we can also specify that the return type for this function should be an integer. By doing this, it makes it a lot easier for the programmer to see what the type should be, and it also helps the IDE out, which means it can give you better error messages. And Python doesn't enforce these data types, so you can see here I have a float and I have an int, and what I've done is I've passed two integers. Python is going to run this completely fine, but Python is still a dynamically typed language and it doesn't enforce any of these types. So even though I've said this is a float and this is an int, I could pass any data type I want to this function. I could pass two ints, two strings, and the function could return a string or a float or anything, even though I've said that it returns an int. And I can prove that, so if I run this function, you can see it prints 3 out every time. It doesn't complain with any errors. Type annotations were actually introduced in Python 3.5, but Python 3.6 takes it one step further and allows you to add type annotations to variables. So Python 3.5 added type annotations to functions, but Python 3.6 adds them to variable declarations. So I had a variable called a, I can say that variable should be an int and it's going to equal 10. So if I run that, you can see I have a variable a and it's equal to 10. I could also say a is going to be a float and it's going to be equal to a string. And that obviously doesn't make any sense, but if I run that, it's still going to work because Python doesn't enforce these types. So that's it for this video. Don't forget to like, comment, favorite, and subscribe. I'll see you next time.